Classify each triangle by angles and sides. If you want to classify a triangle by angles, you're looking at three words. If you see a 90-degree angle, it's considered a right triangle. If all of the angles are less than 90, it's acute, like me. And if one of the angles is greater than 90, it's obtuse. Now, if you're like, should it be all the angles are greater than 90? Look, if all three angles are greater than 90, you're going to have triangles with angles bigger than 180. That's not possible. Knock it off. Now, if I wanted to name these based off of the sides that it has, if all three sides are different, you're looking at scalene. Okay? All three sides are different. If I give you a triangle where two of the sides are the same, it's isosceles. I always am afraid I'm going to spell that wrong, but I'm a math teacher. Who cares? If all three sides are the same, like so, it's equilateral for equal sides. Equilateral. Equilateral. All right. So those are my three things. So let's take a look at what we have here. This first triangle right here, I have two sides that are the same, which tells me that it's isosceles. And one of my angles is a 90-degree angle, so it's isosceles and right. Yeah, there you go. No numbers needed for this one. For this one, I'm going to look at my sides first, and I see that side is different from that side, which is different from that side. So all the sides are different. If all the sides are different, that means we have a scalene triangle. Looking at all three angles, 57 degrees, 44 degrees, 79 degrees, all of these are less than 90, which tells me that it's acute triangle. And last but not least, we have this triangle over here where this side is different from that side, but these two sides are exactly the same. So we have ourselves another isosceles. What makes this one different from this one is that angle is greater than 90, which means this triangle is obtuse. So the types of triangle that we didn't hit, we hit a right, acute, and obtuse, but we didn't hit an equilateral. And if you're thinking, well, equilateral and isosceles, isn't isosceles a type of equilateral or vice versa? There are many ways that you could name these, but this is as specific as we can get. Okay? So there you go. Triangle BAC, baby got that, is congruent to triangle LMN. Okay, so here's pictures. It wants me to figure out what angle A is congruent to. Two ways that you could do this. Angle A is telling me that it has two little hoopy things, which matches up with that M over there, which also has two little hoopy things, which means angle A is congruent to angle M. The other way that you could figure this out is A is the second letter here, and M is also the second letter here. And the only way that you could say two triangles are congruent to each other is if you line them up the exact way that they're supposed to be lined up. So I can look at this and say that C and N are congruent, and B and L are congruent. Without looking at the pictures, I can tell you that side AC is congruent to MN, so on and so forth. But that's all we're doing here. I'm giving you two congruent triangles, and I'm saying, look, A corresponds to which one over there? M. That's it. I'm done. Write a statement that indicates that the triangles are congruent. So when you're writing out a congruency statement, you're going to say triangle blah is congruent to triangle blah. It's important that it doesn't matter which letter you start out with. So if I start out with D, I have to make sure that the order I put it in has the thing that corresponds to D. D has three lines attached to it. I guess that's an I has three lines attached to it, so D and I correspond to each other. So over here, if we pick a different letter, and it doesn't matter which letter that you pick, it doesn't matter the order if it's just a triangle. So if we go with C, C has two hoopy things attached to it, so does H, so C and H correspond to each other. Last but not least, I only have one letter left, so I have B, which matches up with G, B, and G, and we can say that triangle DCB corresponds and is congruent to triangle IHG in that order. Now, the reality is we have an infinite amount of, not an infinite, like 4 or 5 ways, that maybe 6 ways that we can write this out. I can write this out as CBD is congruent to HGI, or I could do BCD is congruent to GHI, as long as D matches up with I, C matches up with H, and B matches up with G. It's all good as long as you put things in the corresponding order. State if the two triangles are congruent. If so, how? So we are going to look at 2 methods of triangle congruence. We are either going to deal with SSS, and SSS says if I have 3 sides of a triangle here that match up with 3 sides of a triangle over there, then these guys are congruent, SSS. And I'm also going to look at SAS. This is where you have to be a little bit more careful. SAS says that if that side is congruent to that side is congruent to that side, the angle in between, the included angle, has to be congruent too. Okay, SAS were the angle in between. So these are the 2 methods that we're going to look at. So I see a side matching up with the side. I see another side matching up with another side, and you might be thinking, that's 2 sides, and I don't see any hoopy things for angles. Neither of them. Incorrect. Don't forget about this included side right here, homie. A side is equal to itself. That's reflexive property. So this guy is SSS, or if you're a snake, it's my favorite geometry joke. So if you're thinking, oh, okay, I wonder if the same thing's going to happen here. Probably. We have a side matching up with the side. We have an angle matching up with an angle, and the included side here. Side, angle in between, side, side, angle in between, side. This is SAS. Right. Over here, we have a side matching up with the side. We have an angle here matching up with an angle. And we have these 2 sides are the same. Now, before you get excited, this right here, side, angle, side. This one is not. This is angle, side, side. Also known as, you know what? Not going to write it out. But what I know is SAS is not the same as ASS. They're not the same. So are these 2 congruent? No. These 2 were yes. This is a no. There are many ways that you could tell triangle congruence. The curse word is not one of them. Not at all. State what additional information is required in order to know that the triangles are congruent for the given reason. So I need to prove that these 2 are congruent by SAS. SAS is called SAS because you have a side and an angle in between and a side. So if these 2 sides are congruent, the angle that I have to draw must be in between the 2 sides, the included angle. Similarly, GH and IH have to have H as my angle. So the information that you need is you need to show that angle L is congruent to angle H. Once I show that, I can say side, angle, side, side, angle, side. The 2 triangles are congruent. I'm done. State if the 2 triangles are congruent. If so, how? The 2 triangle congruencies we're going to look at is ASA and AAS. Now, in a previous example, we did SSS and what was it? ASA? No, SAS. Okay, we're doing ASA here. Also, ASA is a way that you can call your friend. Anyway, what does ASA look like? Well, if I give you 2 triangles, ASA means I have to show that these 2 angles are congruent, these 2 angles are congruent, and most importantly, the included side, the side in between those angles, have to be congruent too. AAS says if I have 2 triangles, I can have an angle and an angle. an angle, and an angle, but a side that is not in between be congruent. So the difference between ASA and AAS is the order of the letters, where ASA says the side is in between the angles and AAS says that the side is not in between the two angles. So what do I have here? I have these two angles are the same. I have these two angles are the same, but I don't have a side. Oh, wait a minute. Yes, I do. It's the included side in between. These sides are the same exact side, which means they're equal. So I have angle, side, angle, ASA. What do I have over here? I have a side, I have a side, I have an angle, I have an angle. No other pictures. I don't have an included side. Oh, but you know what I have? Vertical angles. So I have angle, angle, not included side, angle, angle, not included side, AAS. All right, I have a side and a side. No angles, nothing's attached to each other. There's no right angle thing. I can't even prove anything. Are these two angles or triangles congruent? I don't know. But do I have enough information to say if they are or aren't? Nope. So these two guys are congruent. This guy is not because I only have two sides and nothing else. And I continue to ask my snake friends, is there a S one? And they said, no. It's a snake joke for you. Because of the two S's. Which I have to be careful because there's SSS, which is S. But notice I didn't say S. I said S. Because two S's are shorter than three. Please watch these videos and comment and like. I'm trying as hard as I can here. State what additional information is required in order to know that the triangles are congruent for the reason given. All right, two triangles. I need to show that these guys are congruent by ASA. ASA, in this order, says that an angle and an angle must have a side in between. So angle, angle, I need that side in between. Angle, angle, I need that side in between. So in order for these guys to be congruent, I already have my two angles, but I need to show that side KL is congruent to side, I have to make sure I do it in order, UT. Now, a lot of you are like, why did you put TU and why did you put UT? Why did you stutter for a second there? Because K matches up with U and T matches up with L. I have to make sure I put it in order. But now I have enough information to prove that these two angles are congruent based on ASA because I made the side in between those two angles congruent. Done. State if the two triangles are congruent. If so, how? Right triangles, right triangles, right triangles. I have 4 right triangle congruence theorems, and those are HL, HA, LA, LL, and LA. Good start. What does HL mean? HL means hypotenuse leg. If I give you 2 right triangles and I show you that one of the legs is congruent and the hypotenusae, I don't know, are congruent, that's enough information for me to say these 2 triangles are congruent to each other. HA says if I give you a right triangle and I have an angle and that matches up with a right triangle and an angle here, and the hypotenusae are congruent, that's enough information for me to say that these 2 are congruent by Ha. It's a really funny theorem. LL, which is a really cool theorem, LL Cool J, the singer from the 90s, he's a rapper, says that if I have 2 right triangles and I can show that that leg is the same as that leg and that leg is the same as that leg, I have enough information for me to say that these 2 guys are congruent. And LA, which is a city in California, if I have 2 right triangles and if I can show that one of my legs is congruent and one of my angles is congruent, then that's enough information there. So you might be looking at these and saying, like, isn't that the same as like SAS? And isn't that the same as AAS? Yeah, they pretty much are. It's just that we are making this now towards right triangles, and I'm not going to overthink it. So right triangle, angle, hypotenuse are the same. That's HA. Okay? Angles, hypotenuses, right triangle, ha. What do we have here? We have a leg and a right triangle, but I have nothing else, do I? I do. These two legs are glued together. So we have LL, right triangle, LL. Bean. Isn't that a thing? And then we have H here, L here, L here, right triangles, HL. So the only one that I didn't do was LA, but you guys get the idea. Those are my right triangles. Bada bing. State what additional information is required in order to know that the triangles are congruent for the given reason. I need to show that these two triangles are related by LL Cool J, which is a rapper from the 90s. I made that joke in a previous video. I'm not going to stop until I stop doing math for a living. I need to show that these two are congruent. Well, LL implies that these two guys are right triangles, which they are. Good. I have one leg and I have the other leg. So how can I show that these two triangles are congruent using LL? Should I choose these lines? No, because that's an H, hypotenuse. I'm going to choose these two lines. So I need to prove that line CA, that's my daughter coughing, there she goes again, is congruent to XV. There she goes again. Now, I'm putting it in that order. C matches up with X and A matches up with V. You have to make sure that things are in order when you're writing out congruence statements. I did. CA for cough and XV for... But now I've proven that these two guys are congruent. There you go. Given AB is congruent to CD, all right, you guys, and given BC is congruent to AD, so you guys prove that ABC is congruent to CDA. All right, when I'm being asked to prove two triangles are congruent, I'm having four major thoughts in mind. SSS, SAS, ASA, and AAS. And what I want to do is I want to try to find a way to come up with either one of these four to show that these guys are congruent. Well, looking at this picture, I have two sides already, which eliminates U2. Now, can I find a way to show that angles are congruent? No. I don't see a third side. Oh, except the fact that AC is like a common side with both of these triangles. So technically, right there. And I could use SSS. So this is a three-step proof maybe. So let's get started. One is the given. All right, AB is congruent to CD, and BC is congruent to AD, given. Side. My third side is to show that AC is congruent to itself. So AC is congruent to AC. Now, whenever you say that a side is congruent to itself or an angle is congruent to itself, you are using the reflexive property. Now that I have all three of my sides, I can say that triangle ABC is congruent to triangle CDA. And the reasoning for that is SSS, side. Pretty quick proof, not so bad. Very intro to triangle congruence proofs. I like it. Given AB is parallel to CD and AB is congruent to CD, prove ABC is congruent to DCB. All right, I have two sides. That's all I'm given. So this is me doing a rough draft. Whenever I'm trying to do triangle congruency, I'm thinking 4 major proofs that I could use: SSS, SAS, ASA, or AAS. Now I have my sides. I have a pair of sides. Ooh, BC is congruent to itself. So I have a second pair of sides. So you're eliminated and you're eliminated. These parallel lines, what can I do with that? Oh, when I have 2 parallel lines, alternate interior angles are congruent. So I can say that I have a side, an in-between angle, and a side. I could use SAS for this. So I'm going to start out with my given, then I'm going to show that BC equals BC, and then I'm going to show that ABC is congruent to C or DCB, angles using the definition of alternate interior angles. So let's write out our given first. That AB is parallel to CD, and AB is congruent to CD given. It doesn't matter the order that you do these. This is just the order that I discovered them. So I could say CB is congruent to CB, and whenever you say that a line is congruent to itself, that is the reflexive property. Okay, reflexive property. Now I could say that angle ABC is congruent to angle BCD, and that is by definition of alternate interior angles. Those parallel lines make this happen. Alternate interior angles. If your teacher lets you use shortcuts, take advantage of that. Now that I have a pair of sides, check, another pair of sides, check, and the angle in between, I'm allowed to say that triangle ABC is congruent to triangle DCB, and the reasoning for that is side angle side. So this required a little bit of thought. Not too much, but not so bad. I'm done. Given WU is parallel to YV, XU is parallel to ZV, and WX is congruent to YZ, prove these two guys are congruent. All right, so these are my congruency rules. I have SSS, I have SAS, I have ASA, and I have AAS. Took a second there. I have congruent sides right there. Okay, so I have an S. Great. What it also gives me is I have 2 sets of parallel sides, 2 sets. Now, usually when it gives you parallel lines, you are thinking thoughts of alternate interior angles. Okay, alternate interior angles. These, but you know what? No, I don't want that here because that's not really what's going to help me. What I'm going to have is, since ZV and ZU are parallel, this acts as a transversal. These two correspond with each other. So these are going to correspond. Similarly, since these two guys are parallel, these correspond. And so what I have is I have an angle with the side in between an angle. I have ASA. So I'm going to state my given. I'm going to say that these two angles are congruent because they correspond. These green angles are congruent because they correspond. Therefore, the triangles are congruent from ASA. So, number one's my given. Okay, WU is parallel to YV. XU is parallel to ZV. And WX is congruent to YZ. That gives me my side right there given. Okay, let's go with the red angles. Angle VZY is going to be congruent to angle UXW. And the reason for that is the definition of corresponding angles. Ready to kill two birds with one stone? Let's say that in the same exact statement. Why repeat myself? Let's say ZYV, angle ZYV, is congruent to angle XWU for the same exact reason. And if you're like, oh, yeah, you could do that in one step, why not? If you have the same exact reason, just give both statements in one. Don't overdo it. Now that I have an angle congruent, and the side that happens to be in between congruent, I can now say that triangle WXU is congruent to triangle YZV. And the proof that I used for that was ASA. That's it. That was actually friendlier than I thought. I thought it was going to be bad. But the only thing that's bad is Michael Jackson. You know it. It's a song. Look it up. It's called Bad. Rest in peace, Michael Jackson. Well, don't rest in peace, actually. Like and subscribe. Given OM is perpendicular to LN and OL is congruent to ON, prove that these two triangles are congruent. All right. So let's figure out what we have. We are given this, that is a side. We are told that these guys are perpendicular, which means we are allowed to say that these two angles, and let me use a different color, we are allowed to say that these two angles are right, which means we could say that these two triangles are right triangles. Now I have, all right, so if they're right triangles, I have HA, HL, LA, and LL. So I have the ones involving a hypotenuse. So these guys are out of the question. So I have a hypotenuse. What else do I have? Oh, these guys are the same line. So if I can say that OM is congruent to OM, which I can, that gives me a hypotenuse and a leg. So I'm going to prove that these two are congruent. I can show that these two are congruent by HL. So let's go through all the steps. Step number one is the fact that OM is perpendicular to LN and OL is congruent to ON. That's my given. Always start out with the given. Step two is that angle OML is equal, they are equal, but let's do the right angle stuff. OML and OMN both measure out to 90 degrees. So the measure of OML equals 90 degrees, and the measure of OMN is 90 degrees, and this is by definition of perpendicular lines. Okay. Which means we are allowed to say that the measure of angle OML is congruent to the measure of angle OMN. And that is through the transitive property. Now, a lot of people might be like, well, why do we have to write out both of those steps? You kind of do. It's dumb, but you kind of do. You have to show that they're 90 degrees, and then you have to show that they're equal. And now that they're equal, you're in good shape. Now, what I can say, let's use a different color, is OM is congruent to OM by the reflexive property. Whenever you say that two lines are exactly the same, because they are the same, you're using the reflexive prop. And since I showed that these guys are right triangles, I showed that I have a leg right there and a hypotenuse up here that was given to us. I can say that these two guys are congruent. OML is congruent to triangle OMN, and that's by using the hypotenuse leg postulate. My leg, SpongeBob. Remember that? Good times. Given angle XYW, which is XYW, that guy, weird, is congruent to that guy. I don't know why it just doesn't say that they're congruent. Why did it have to give me the right angles? But oh well, they're right angles. Also, we're told that this guy and this guy are congruent. This is weird. I need to show that these two lines, WX, is parallel to ZY. I need to show this. Now, I don't know this. I need to show this. So this is what I'm thinking. This is how my brain operates. There is a rule called CPCTC. Congruent parts in congruent triangles are congruent. Lots of congruence. It's corresponding parts of congruent triangles are congruent. Whatever. What that means is if I give you two triangles that are congruent, I can say that these guys are the same, and these guys are the same, and these guys are the same. So what I can do is if I show that these two triangles are congruent, then I can prove that these angles are congruent, which means I can show that blue plus purple is congruent to blue plus purple, which means by definition of alternate interior angles, I have parallel sides. I know that's a lot. Bear with me. Step number 1 is my given. Okay. Now my given, once again, gave me two angles. What I have is a shared side. That shared side is going to have to be explained. I have to say, and it's stupid, it's always been stupid, but WY is congruent to WY. And that's the reflexive property. My 5-year-old daughter is in the room and she's giving me a stink eye because I said stupid several times. It's a dirty word in this house, isn't it? She's nodding her head, I swear. Those of you who are addicted to my YouTube channel, that's the famous Kelsey. All right. Now I have two angles. Ooh, and a non-included side. That's AAS. So I can say that these two triangles, so let's put it in order. Y matches up with W. So let's make sure I say that. Y matches up with W. Z matches up with X. So X, Z, and what's left? Y, hold on, Y, Z, W, W, X, Y. And the reason for that is AAS. Now, that's maybe we're halfway done. Now, the purpose of me showing that these two sides or these two triangles are congruent is now I can say that these two angles are congruent. These two angles are congruent. So I can say the angle XWY is congruent to angle WYZ. And the reason for that is now that these are congruent triangles is that corresponding parts of congruent triangles are congruent. Okay? Okay. Step 5. This angle, ZWY, plus YWX equals angle, I did these two, so XYW plus angle ZYW. Yep. And the reason for that is a bunch of substitution that I did up here without doing a whole bunch of substitution. So my reason for that is substitution property. Since these two guys are the same thing, right? These combine to make alternate interior angles. Maybe let's add one more step. Let's say ZWX is congruent to XYZ. And the reason for that is the angle addition postulate. One letter away from a retirement plan, AARP. And now that we know that, these two angles are all completely the same, these two guys are the same as these two guys. Now that we know that, I can say that this is parallel to that, thus finishing my proof. Let's get a different color. I can say that WX is parallel to ZY, and that's definition of alternate interior angles. So this problem wasn't pleasant at all. Not at all. Not one bit. I had fun, though, and I said a couple dirty words in the process, didn't I, babe? She's nodding her head. She knows she's not supposed to talk during these videos. She just loves to hang out. She loves to soak it in. Either that or, for all you know, I'm going crazy and I'm talking to a ghost.
In this episode of Everyone Proofs, we're going to talk about the 4 different types of triangle congruency. The first 4 have to do with non-right triangles. Those are SSS, 3 congruent sides, SAS, 2 sides with an angle in between, AAS, 2 angles with a side off to the side, and ASA, 2 angles with a side in between. The 4 right triangle proofs are HA, which deal with a hypotenuse and an angle, HL, which deal with the hypotenuse and a leg, LA, which deal with the leg and an angle, LL, which deal with 2 legs. The ones that don't exist are AAA, ASS, the curse word, or the backwards version, SSA. Those don't exist.
Proof 1 of proof 5 proofs. Write a 2-column proof. I'm given BA is congruent to DC. So one side BA is congruent to side DC. So that's this guy, that's this guy. I'm also given that BAC, angle BAC is congruent to angle DCA. That's BAC is this guy, and DCA is this guy. Okay? Okay. So this is what I have so far. And I like what Ms. Harris did the other day, so I'm going to copy what she did. She wrote out the fact that we have a side right here. These two sides are the same. Also, you have an angle right here. Now, when you have two triangles glued together, which is what I have, 99% of the time you're going to use the Santiago special, and that's going to be this side in the middle. And of course, dummy over here forgot to write out given. Dummy over here. Now, what was I saying? Okay, so I have the San Diego special. I have the San Diego special, which means I have AC is congruent to AC. And we know that to be the reflexive property. I'm ignoring that. Now, I can say that these two triangles, ABC, are congruent to each other. So I guess that would be CDA. And since I have a side and an angle, and now a side, the angle is inside the side. Side angle side is going to be SAS. I know it says prove here that two sides are the same, but we're not going to do that. We're just going to stop at the fact that the proof, we're proving two angles or triangles are the same. So we're going to stop right there. That's proof number 1 of 5 proofs. Okay, so the trick here is you're usually given 2 facts or 1 fact, and you have to find out another fact. And the 2 facts that we were given was a side and an angle. A side and an angle. So I know it's going to be one of the SA ones. It doesn't say anything about these being right triangles. So we can't assume that these are right angles. I know you want to, and I know you want to be like, well, that's kind of like HA, but it's not. We don't know if that's true or not. So we had to find a third thing, and that was the third side. And by finding the third side, we were able to say S with an A in the middle of another S. Yeet! I'm going to zoom up on that part real quick because it's kind of hard to see. Yeah, I don't think I'm going to get it much better. Terrible job by me getting such a bad picture. Terrible job by me. Let me do this at least. Try to straighten things out. And try to clear that up. Okay. So I'm going to write out the given anyway. So don't freak out too much. Okay. This is what the given says. Angle W is congruent to angle Y. All right, so even if you have a hard time seeing the wording, you can still see the letters. That angle W is congruent to angle Y, so I have an angle. Okay. Also, this says that WZ is congruent to YZ. So that's WZ right here is congruent to YZ. Now, I know what you're thinking. You're thinking the Santiago special. I'm sorry, I mispronounced it. The San Diego special. And you can't, though. If you think the San Diego special, then the proof that you're trying to do is the AS other curse word. And there is no curse word proof. Okay, and if you're wondering, well, no, isn't it SAS? No, because if you were to use the San Diego special, you are doing a side. And since there's no angle in between the side, then you're creating the curse word, which we're not allowed to do. Okay, so we have to rely on the fact that XZ bisects angle WZY. All right, so all of this is my given. Now, in my Instagram and in the class the other day, we looked at this phrase in particular very, very, very closely. Okay, so let me be clear again. If I see the word bisect, I'm looking at two things. If it says the phrase, this bisects an angle, then what we all of a sudden care about is the two angles being congruent to each other. If it says this bisects a side, then all of a sudden I care about the two sides being congruent to each other. You can't see that. So the wording is extremely important because here it says XZ bisects an angle. And since the given is telling me that my line bisects an angle, I now care about two angles being congruent to each other. Since it talks about bisecting an angle, I now care about two angles being congruent to each other. So XZ bisects WZY. So it bisects this angle down here, WZY. So since it bisects the angle, this angle is going to be congruent to this angle. And so what we're going to say is WZX angle WZX is congruent to angle YZX. And that's because of the word bisect here. So we will say definition of bisect. So now what I have in my picture is I have an angle, side, angle. I have two angles with the side literally in between. So my final answer is now I can prove that XWZ is congruent to XYZ because of angle, side in the middle of another angle, ASA. And that's my wife yelling at my children if you can hear it. Okay. Again, the key word is you want to think San Diego special. San Diego special. But you can't hear because it gives you the curse word proof. And just like we don't use curse words in real life, we don't use them in math either. Right, gang? Yes, Mr. Parrott. Thank you. This one's different. I believe I was going to do this one the other day and we ran out of time and I was like, nah. And I was all like, nah. So let's analyze what we have here. Triangle QRS. So that's this whole triangle. Triangle QRS. I meant hooves. I don't know what that means. Obviously, I said something. Angle, oh yes, angle QRS is isosceles with QR being congruent to SR. Okay, so that's thing number one. Triangle QRS is isosceles with side QR being congruent to side SR. Listen, man, I don't remember what I had for breakfast this morning. Asking me to bring up what I said at Christmas time is a different story. What other information do we have? Ah, yes, the old bisect word. Angle side RT bisects side QS at point T. That's my given. That's my given. All right. So I was told one thing. I have to use the information that I have to find other things. And let's do, which one do I want to do first? Let's do this. Let's do the order that it gave us. If QRS is an isosceles triangle, not only are two sides congruent, two angles are congruent as well. So if these two sides are congruent, then these two angles, the angles opposite of the sides, are going to be congruent too. So we could say angle SQR is congruent to angle QSR. And that's the definition of an isosceles triangle. Oof. I have to remember that orange doesn't show up well at all. Shame on me. Am I allowed to do the Santiago special for this? Am I allowed to do the San Diego special? I can't, because if I do, it gives me an angle, side, and then the side. And since it's not, it's angle, side, side, and the angle's not in between the sides, it's the curse word, so I'm not allowed to do the curse word. So I'm going to use this second fact. If RT bisects QS, then that means QT, the side is obviously named after me, is congruent to TS. Now, remember, in the last problem, it said this, that a line bisects an angle. And so since the line bisected the angle, that led us to say that two angles are congruent. Here, it's saying a line bisects a line. So we could say two lines are congruent to each other. QT is congruent to TS, and that's by definition of bisect. So now what we have is we still have, and if you're wondering, well, wait a minute, we couldn't do the San Diego special because the you said because there would be another side. I did. But in this case, we have a side with an angle in between another side. You're not allowed to do it otherwise because it spells out a curse word. And cursing is one of the many tools that the devil uses to make kids make bad choices. And I'm going to agree with Santiago that we have QRT. QRT is congruent to SRT because of SAS, he said. And here's how you know it's SAS. Side, angle in between another side. Side, angle in between another side. Again, it's just like the first problem that we did. It's very tempting to want to do one of the right triangle ones, like, you know, an HL or something like that. And in this case, it would be the HA, but we don't know if this is a right triangle or not. We don't. So since we don't know, and since we're not given absolute proof, we can't just assume that it is. If it doesn't say anything about right triangles, if it doesn't say anything about midpoints, if it doesn't say anything about angle or whatever, you can't do it. Oh, and wouldn't you know it, it's almost as if I led you to this creek to drink out of the delicious waters of a right triangle waterfall. Given AD is congruent to BC. So AD is congruent to BC. So this one and this one. Also, A and C are right angles. Angle A and angle C are right angles. That's my given. We now have information about right triangles. So I am allowed to use either HA, HL, LA, or LL. And of course, this stands for I have a hypotenuse and an angle, I have a hypotenuse and a leg, I have a leg and an angle, and I have a leg and a leg. Well, right now, all I have is a leg. This is a leg. Remember, the legs are the shortest sides, and the diagonal, the longest side, is always going to be the hypotenuse. So I have a leg. So this one's out of the question. At least I don't need this one, because I have a leg. Can I use the St. Diego special here? Could I use the San Diego special? Yes, I can. Yes, I can. I could say that BD, for best dude, is congruent to BD. And that's reflexive. Do I have enough information to use one of these three? You sure do. You sure do. I can now say that ABD is congruent to CDB. And which one of these remaining three can I use to prove that those two triangles are the same? Is it going to be the HL, the LA, or the LL? It would be the HL, because I have two hypotenuses that are the same, and I have two legs that are the same. And since this is a right triangle, I'm automatically given an angle. A hypotenuse is the longest side of a right triangle. So if you were to isolate one of these right triangles, the longest side would be DB or BD. The slant. What do we use? HL. So far in all of these problems, I was allowed to use the Santangelo special, but only in 2 of the cases would it actually help me. Now, if you remember the picture that I posted on the diagram the other day, and we went over in class, and then I posted it on diagram, we focused on 3 things, and we hit on all 3 things today. The 3 things that we cared about when I posted on diagram the other day was if you see this phrase, a side bisects a side. And so when that happens, you could say that 2 sides are equal to each other. We also saw the phrase, a side bisects an angle. And then so we were able to say that 2 angles are the same. And now today, we're finally seeing this thing, that 2 sides are parallel to each other. Even before that, we see another word, midpoint. So one of the things I want to stress, and I already stressed it earlier today, is sometimes when you guys would do your proofs, you would say, oh, these 2 sides are congruent because of the word midpoint. Like, it's very, very, very tempting to do this problem and try to explain something by saying, oh, blah, blah, blah is the midpoint. But since we don't talk about midpoint anywhere in the given, we are not allowed to do that. So you're not allowed to say, well, this is equal because of midpoint if it never says midpoint. Or this is equal because this is a bisect if it never says bisect. Like in any of my explanations here, like I might want to say like, oh, look, V is right in the middle of everything, so V bisects stuff. Well, I'm not allowed to say that. And I'm not allowed to say that because nowhere in here does it say the word bisect. So make sure on the test, if you see the word bisect, you use the word bisect. But if you don't see that word, don't use it. Now, I'm obviously going to use the word midpoint, and I'm obviously going to deal with these parallel lines somehow. Okay, so let's do the midpoint. Let's write it all out first. V is the midpoint of WY. I'll explain what that means in green. Just give me a minute. UI is parallel to XW. All of this be my given. All right. V is the midpoint of YW. What does that mean? V is in the middle of YW, which means YV and VW are congruent. Am I allowed to say that UV and VX are congruent? No. And here's why I'm not allowed to say it. Because it never says that V is the midpoint of UX. So even though it probably is, I'm not allowed to say that. I'm not. All right, so first thing number one that we're going to write out is since V is the midpoint of YW, I'm allowed to say that YV is congruent to VW. Volkswagen! And that's the definition of midpoint. The key with parallel lines is whenever you see parallel, that usually leads to alternate interior angles. So what I can say is since UY is parallel to XW, I could just pick these two angles and say these two angles are congruent. So angle UX, or U, is congruent to angle X. Now why these? Because these are the alternate ones. You know what else I could say? I can say that angle Y is congruent to angle W. And the reason for these guys is the definition of alternate interior angles. Now, a lot of you might be thinking, let's go one step further and say that these two angles are congruent because they're vertical, which is 100% true. But you know what? I don't have to do that. Why? Because right now I can say that triangle UVY is congruent to triangle XVW. Because there is such a thing as angle, angle, side. There is an AAS. And I'm done. And before we call it a day, remember you have 8 proofs. You have 8 different types of proofs. Okay, you have SSS. So if you have 2 triangles, right, and you're able to prove that that side, and that side are all the same, then you have 2 congruent triangles. You have SAS. So if you can prove that, let's do this. If you can prove that that side is congruent to that side and that side is congruent to that side, and you're like vertical angles, then what you have is a side with an angle in between another side. That's SAS. You have AAS, which is what we just did. AAS is if I give you 2 triangles and you're like, here's an angle, here's another angle, and the side not in between them. Angle, angle, side. Angle, angle, side. You have one of those. One of those. You have ASA. So that angle is the same as that angle, and these 2 angles are the same. And in between your congruent angles, you also have a congruent side. Those are your 4 main ones. From there, we also have hypotenuse angle. So if I give you 2 right triangles, tell you that these are definitely right. See, in these, even though some of these might look like the green one right there, that looks like a right triangle, do I ever say it's a right triangle? No, then I can't prove it. If I give you the right triangle information, you're like, here's an angle, these 2 angles are the same, and look, they're the same hypotenuse, then I have an HA. If you have an HL, and I have definitely a right triangle, and definitely a right triangle, and I can show that 2 of the hypotenuses, or both hypotenuses are the same, and that a leg on each are the same, then I have HL. I also have LA. So if I have definitely a right triangle, definitely a right triangle, these 2 legs are the same, and these 2 angles, any 2 angles are the same, then I have LA. And last but not least, I have LL. So if I have, that's definitely a right triangle, that's definitely a right triangle, that leg is the same as that leg, and that leg is the same as that leg, then I have LL. The ones that don't exist, there's no such thing of, there's no such thing, oh, you know what, I don't want to do red again. There's no such thing as AAA. There's no such thing as AAA, and there's no such thing as the curse word. So you can't be like, oh, look, these 3 angles are the same. They're congruent because of AAA. There's no such thing. Oh, look, you have an angle, and that side, and that way, other side way over there. No, that's the curse word. Can't do that.